Hey, Hawks. So today we're going to talk about motion in a circle, and we're going to talk about it using descriptions that we've already used. So we're going to use linear language. Okay. Our learning target is I will describe and calculate the displacement, velocity, acceleration, and forces applied to an object in circular motion, including objects in orbit, forces due to friction, gravity, and tension. Okay, so first off, objects moving in a uniform circle are not that different from those moving in a straight line. Okay? They still have the basic forms of motion like displacement, velocity, acceleration, force, etc. Right? The differences are that because it's moving in a circle, we have to apply different mathematics to it, right? To figure out the length. All right. So objects moving in a uniform circle, this means that they're moving in a perfect circle, okay, are described using displacement, where the displacement is 2 times pi times r, right? That's the circumference of the circle. And then the number of times that you go around that circle, right? So n is the number of times that you go around the circle. Velocity is v equals 2 pi r, that's our distance, divided by the time period. And that means the amount of time it takes to get around the circle once. Okay? All right. Objects moving in a uniform circle have the same speed, okay, or magnitude of velocity, but are constantly changing direction. Therefore, they are always accelerating. Okay? So even though the speed of this object is exactly the same all the time, because it's changing its direction, it's always accelerating. The acceleration is pointing inward, okay, to the center of the circle. Therefore, we refer to this as the centripetal acceleration. Okay? Centripetal, not centrifugal. Centrifugal does not exist. Okay? The magnitude of the centripetal acceleration is equal to the velocity squared, the linear velocity squared, divided by the radius of the circle. Okay? The force holding the object in the circular pathway also points inward, and is called the centripetal force. If the force was suddenly removed, the object would continue going in a straight line. So, if for some reason this object was just all of a sudden let go, right? It would keep going in a straight line. It wouldn't keep going in a circle. Okay. For force, centripetal force, force is equal to mass times acceleration, and mass and force, acceleration, centripetal acceleration is v squared divided by r. So that means that the force is equal to the mass times the linear velocity squared divided by r. Okay. In our picture, it's just showing what are the different forces that are causing the rotational motion. Okay. So here's an example. I have a 5 kilogram object, and it's spun around in a circle of a radius 1.3 meters with a period of 4.5 seconds. Remember, period is the amount of time it takes for it to go around a circle once. What is its linear velocity? So remember, velocity is distance divided by time, and in this case, it's a circle. So our distance is 2 pi times r, and then divide by t. So we're going to do 2 times pi times, in this case, 1.3 meters, and divide it by the period, which is 4.5 seconds. When you do that, you get 1.8 meters per second. Okay. What is its centripetal acceleration? Remember, acceleration is the linear velocity squared divided by the radius of the circle. So we're going to do our answer from before, 1.8 meters per second squared. And we're going to divide that by the radius of the circle, which is 1.3 meters. And we end up with 2.55 meters per second per second. Okay. What is the force acting on the object? Again, F is equal to mass times acceleration. So in this case, we can just take the 5 kilograms and multiply it by the 2.55 meters per second, which gives us 12.75 newtons, 12.8 newtons. We could have also done 5 times 1.82 squared divided by 1.3 and gotten the same answer. Okay, so to sum it up, objects moving in a uniform circle are described using displacement, which is 2 pi r, velocity, which is 2 pi r divided by the period. Centripetal acceleration is the linear velocity squared divided by the radius. And the centripetal force is the mass times the centripetal acceleration, or mass times the linear velocity squared divided by the radius of the circle.